Okay, students. Now we'll see that. Now I hope you understand what is the use of modulation, how the importance of modulation in the communication system, right? Right. Now we'll see basics of some concept of modulation, notations. What is the notations of message signal and all these things. Now see here. Now this is M of t, which is low frequency information signal. Low frequency information signal. This is the low frequency information signal, or we call it as, this is a signal which is going for modulation, therefore modulating signal, or we call it as a message signal, or this is called as baseband signal. Baseband signal. What is the meaning of baseband signal? A signal which is having significant low frequencies. A signal which is having a significant low frequencies is called as baseband signal. Okay. Or we call it as a band limiting signal. A signal is having a limited bandwidth. Now a baseband signal is a signal which is having significant low frequencies. A signal which is having significant low frequencies is called as baseband signal, or band limiting signal, or modulating signal, message signal, information signal. Okay, right. Now this signal, the problem of this signal, which cannot transmit it for longer distance, right? The problem of this signal cannot transmit it for longer distance. Now see here, see this one. This is the message signal, right, in time domain. Because this is a continuous wave signal, analog signal, message signal is a continuous wave signal. So this M of t is represented by AM, sinusoidal signal, sine or cos 2 pi fm into t. AM is the amplitude of the message signal, peak amplitude of the message signal. Fm is the frequency of the message signal. Now this is the message signal in time domain, right? Now this is the message signal in time domain, M of t, which is equal to AM cos 2 pi fm into t. Now this is the message signal which is a low frequency information signal, now which cannot transmit it for longer distance. Now see here, now this is the message signal, this is in time domain, M of t, which is equal to AM cos 2 pi fm into t. Now this is a message signal which is a low frequency information signal. This is in time domain, right? This is in time domain. Now in frequency domain means apply Fourier transform. Already we know what is the Fourier transform of AM. AM Fourier transform is a DC signals Fourier transform is a impulse signal in frequency of AM into delta f. But that is shifted right side, that is shifted left side by an amount of fm. So delta of f minus fm plus delta of f plus fm. Like this you can draw the frequency shifting property, and spectral amplitude AM becomes AM by 2. This is the Fourier transform of M of t is nothing but M of f. So what is M of f? Is nothing but impulse functions. What are the impulse? Impulse is existing at, one impulse is at plus fm. F minus fm equals 0. F equal to plus fm. F plus fm equals 0. F equal to minus fm. Now this is AM becomes AM by 2. Right? Now this is the signal in time domain. This is the signal in frequency domain. Now you just see here. Now the message signal consisting of only one frequency, single frequency. Okay. The message signal is consisting of only one frequency. This is called as single frequency. This is called as single tone. This is called as single tone. If the message signal consisting of only one frequency, now which means that single frequency, this is called as single tone, and this signal is a low frequency information signal which cannot transmit it for the longer distance, then you take the help of carrier and go for modulation. Now this single tone signal and take the help of carrier and go for modulation. That modulation is called as single tone modulation. What is that? Single tone modulation means the message signal is go for modulation with the help of carrier. The message signal is modulation. The message signal is modulating with the help of carrier. Then that modulation is called as single tone modulation. Clear or not? No doubt. Clear or not? Now this is the message signal. Not only message signal, any signal is having single frequency. Its spectrum, its Fourier transform is always consisting of impulses. Listen, any signal is having only single frequency. Remember this point, which is very important. Any signal which is having a single frequency, its spectrum, its Fourier transform always consisting of impulses. So this is only one frequency. Its Fourier transform, its spectrum, its frequency domain consisting of only impulses. Okay. Now I'll write here. Now this is m of t. Now the message signal is like this. Now like this. Now m of t, which is equal to am1 cos 2 pi fm1 into t plus am2 cos 2 pi fm2 into t plus and so on. Now the message signal consisting of multiple frequencies, right? Now the message signal consisting of multiple frequencies, fm1, fm2 and so on. Now whenever the message signal consisting of multiple frequencies, this is called as multi-tone signal. Multi-tone signal. Okay, but if it is a low frequency, yes, even if it is a single frequency or multiple frequency, but the concept it is a low frequency information which cannot transmit it for longer distance. Now definitely you need to take the help of carrier. So then message signal with the help of carrier, if you go for modulation, now that modulation is called as multi-tone modulation. That modulation is called as multi-tone modulation. Multi-tone modulation. This is the multi-tone modulation. So in such a situation, now if this is m of t, this is m of t in time domain, this is a message signal in time domain, right? Now in frequency domain, now how you can represent? Now this is m of f. Now this is m of f. Now or you may represent it like this. This is m of f. Or you may represent it any arbitrary signal. What is the meaning of that? What is the meaning of that? That meaning is nothing but, now see here, this is multiple frequencies. So now the spectrum consisting of multiple frequencies FM1, FM2, FM3, FM4, FM5 like this, omega 1, omega 2, omega 3, omega 5 like this, which means that single frequency means impulses, multiple frequencies means there is a range of frequencies. What is the meaning of that? Now whenever there is a range of frequencies, then there is a concept of bandwidth. Am I not? Now what is the bandwidth? The bandwidth of the message signal is the bandwidth of message signal. What is the bandwidth of message signal? If you observe, this is the bandwidth of message signal. The bandwidth of message signal is highest frequency minus lowest frequency. Highest frequency is omega, lowest frequency is 0, which is equal to omega hertz. What is the meaning? Then can any point is you just have in your mind in the starting class of the subject? So this is the bandwidth of the message signal, which is nothing but omega hertz. The bandwidth of the message signal, which is nothing but omega hertz. What is omega? The omega is the, see here, what is omega? Omega is the highest frequency. Omega 1, omega 2, omega 3 like this. This omega is the highest frequency. Omega is the highest frequency present in the message signal. Present in the message signal. That's why what we are observed in our practical signals. What are the practical signals? Voice signal 3.5 kHz, 300 to 3.5. Audio signal 20 to 20 kHz. Video signal 0 to 4.5 MHz. Now what is the bandwidth? The bandwidth is approximately the highest frequency of the message signal. Same, this is the practical application. The bandwidth of the low frequency information, the bandwidth of the modulating signal, the bandwidth of the message signal is nothing but omega, where omega is the highest frequency present in the message signal. Okay, any arbitrary signal which we can represent like this, not the shape important. What is important here? This indicates that there is a range of frequencies, there is a group of frequencies, there is a band of frequencies, because this is a multiple frequencies. Therefore the spectrum is also consisting of multiple frequencies. Then you can able to calculate the bandwidth. Okay, note down. Information signal. Now this low frequency information signal cannot transmit it for the longer distance, then we'll take the help of carrier C of t. This is the high frequency signal. This is the high frequency signal which is called as carrier signal, or this is nothing but carrier before, this is carrier before modulation. This is the high frequency signal, carrier before modulation. This is unmodulated carrier. This is unmodulated carrier, carrier before modulation. What is the carrier before modulation? C of t, which is equal to AC cos 2 pi FCT plus 5. This is carrier before modulation. Now what is AC? Peak amplitude of the carrier. FC, frequency of the carrier, phase of the carrier. This is carrier before modulation. Now because whether it is a single frequency or multiple frequency, single tone or multi-tone, now that signal is taking care signal is nothing but that signal is safely carried by this particular carrier. Therefore these are the carrier characteristic parameters. Of course this is a continuous wave signal, analog signal. Therefore we can take a continuous signal or a sinusoidal signal like this. Okay, so this message signal and this carrier signal together will take the process of modulation. Is it right or not? Now this is a carrier signal, this is the message signal. Note down. Now see here. This is the message signal m of t. Any signal you can do, continuous wave signals, exponential signal, and this is multiplied with carrier C of t. What is C of t? Is a sinusoidal signal. Right? Now see here. Now I am already explained to you. Any signal multiplied with a sine wave multiplied with a cos wave. What is the procedure I am saying? Now first take the original signal. The original signal here is exponentially decaying, then mirror image. Now in the common area, frequency of oscillations. Now this is nothing but m of t multiplied with c of t. M of t multiplied with c of t, right? Now this is the message signal multiplied with carrier signal. Now see here. Now this is the message signal, low frequency information signal. This is the carrier signal, okay, high frequency signal. Now what happened here? Now whenever the modulation is done, any one of the carrier characteristic parameters, whenever the modulation is done, any one of the carrier characteristic parameters are changed in accordance with the message signal is called as modulation. Therefore this is called as modulated signal. Therefore this S of t is represented as modulated signal. This S of t is represented as modulated signal. Modulated signal. Now this is carrier after modulation. Carrier after modulation. Okay. Now this is the modulated signal. Am I not? Now this is after modulation. Now what is the modulation definition? Now here I am explaining the modulation definition also. Any one of the carrier characteristic parameters, any one of the carrier characteristic parameters are varied in accordance with the message signal. Any one of the carrier characteristic parameters, it may be amplitude or frequency or phase, whatever it may be. Any one of the carrier characteristic parameters are varied in accordance with the message signal. Now that carrier characteristic parameters are changed, then that change is nothing but modulation. Now this is the modulation definition in time domain. This is the modulation definition in time domain. Earlier we are writing one more thing also. See here in the previous example. This is the example which we are considered earlier. Now this is the low frequency information, but in which domain? This is the voice information, let us assume, okay? Low frequency in nature, but in which domain? Frequency domain. I am just explaining. This is in time domain, this is in frequency domain. After modulation, what happened? After modulation, the same low frequency information, but this is the low frequency information, but which is available at a high frequency. This is at Fc. This is Fc plus 1 by T. This is Fc minus 1 by T. This low frequency information which is available at a high frequency. This process is called as modulation. This is modulated signal. This is the modulated signal. In which domain? This is the modulated signal in frequency domain. This is the voice information in low frequency signal, right? Now this is the modulated signal in frequency domain. Now see the definition. The low frequency information is transformed to a high frequency. The low frequency region is transformed to a high frequency is called as modulation. There are two definitions of modulation. Now see here, carrier characteristic parameters. Here if you observe, the carrier characteristic parameters. What are the carrier characteristic parameters? Amplitude or frequency or phase. The carrier characteristic parameters are varied. Amplitude or frequency or phase is varied in accordance with the message signal is called as modulation in time domain. Otherwise here the low frequency information is transformed to high frequency region. The low frequency region is transformed to a high frequency region is called as modulation definition in frequency domain. This is the modulation definitions in time domain as well as in frequency domain. Clear or not? This is the message signal which is the low frequency information signal. Now this is the carrier signal. Now AC cos 2 pi FCT plus phi. These are the carrier characteristic parameters. Okay. Now Whenever the modulation is done, what happened? Carrier characteristic parameter is changing. That's why it is called as carrier before modulation, carrier after modulation. Now, carrier characteristic parameters are changed. Means whether it may be amplitude is changes. Now the amplitude of the carrier is changed. Amplitude of the carrier is changed in accordance with amplitude of message signal. Now this is called as amplitude modulated signal, amplitude modulation. Understand or not? Now similarly, now it may be a frequency of the carrier is changed. Now the frequency of the carrier is changed in accordance with same amplitude of message signal, then it is called as frequency modulation. Next, phase of the carrier is changed. Maybe a phase of the carrier is changed sometimes. Now the phase of the carrier is changed in accordance with, again, because information is nothing but amplitude of message signal. Now this is called as phase modulation. Understand or not? If you observe amplitude modulation, frequency modulation, phase modulation, the names are coming because carrier characteristic parameters is changing. Carrier amplitude is changing, amplitude modulation. Carrier frequency is changing, frequency modulation. Carrier phase is changing, therefore phase modulation. Any one of the carrier characteristic parameters are changed in accordance with message signal, but amplitude of the message signal, because amplitude is nothing but information. So I want an information. For saving of that information, whatever you want to do it. So for saving this information, my carrier amplitude is changing sometimes, my carrier frequency is changing sometimes, my carrier phase is changing sometimes. Now this is the modulation technique. Here this message signal is analog, this carrier is analog, this message signal is the analog signal, this carrier signal is the analog signal. Therefore this amplitude modulation, frequency modulation, phase modulation, these are called as this amplitude modulation, frequency modulation, phase modulations, these are called as analog modulation techniques. What is this? This is called as analog, because all are analog signal, analog modulation techniques. These are the analog modulation techniques, AM, FM, PM. Clear or not? Now this is very, very important concept, because all are analog, and all are varying with respect to the message signal and message signal amplitude. Remember that. Okay. Now see here. What is the analog communication or analog modulation techniques? Now this is the analog modulation techniques. Now here it is, amplitude modulation. Now again, in this subderivatives of this amplitude modulation is DSBSC, SSBSC, VSBSC. Now all are the derivatives of AM. Okay. Now here it is FM. Now any FM, now single tone, multitone, that is common. Okay. Now this is a narrow band FM. This is wide band. Now this is PM. Now in this PM also same, narrow band PM, wide band PM. But all these are the analog modulation techniques, amplitude modulation, frequency modulation, phase modulation, all are analog signals, okay. If you finish this, the analog modulation technique is completed. How the modulation, how the demodulation, what is transmitter, what is receiver, what is bandwidth, power, all these things we have to calculate. Okay, not on this. Now this is the way how we are calculating the this is the basics. Whatever so far we cover is the basic portion. Now after the next class we will start with the analog modulation techniques starting point, okay, with the AAM.